Let's talk more about genome editing. We now know that genome editing is the insertion, deletion, or replacement of DNA using nucleases. There are a number of different nucleases being used for genome editing, such as meganucleases, zinc finger nucleases, transcription activator-like effector nucleases, and the CRISPR-Cas9 system. The Cas9 system is the most modern and innovative method, so this is most likely to be the focus of future ethical issues. Whilst this may seem like a breakthrough, there are a number of issues with CRISPR-Cas9 and genome editing itself. Firstly, assessing the risks versus benefits. The disadvantage of CRISPR and other genome editing methods is that they are not 100% accurate, producing off-target mutations. With CRISPR, scientists found that humans suffered a greater risk of off-target mutations than mice or zebrafish. The consequence of drastically altering the genome for the worse may not be worth the risk to try and alter it for the better until methods are safer. Secondly, there are environmental issues. Genome editing on various organisms in the laboratory may mean passing on negative traits. Scientists need to ensure that such organisms are contained within the laboratory and pose no risk of escape into the environment. Potentially, such traits could be passed on throughout the species and cause ecological disequilibrium. What about genome editing for enhancement? Some argue that genome editing could be used to edit somatic or germline cells to improve upon one's genetics. For instance, athletes could enhance their performance, violent offenders could be treated to be made less violent, and therapeutically it could be used to enhance a patient's health. However, this may lead to social problems if populations or nations are using genome editing to give themselves an advantage over others. Finally, there is genome editing of germline cells. This poses a number of ethical issues. Edits in the germline cells will be passed on to all future generations, posing an issue of informed consent. Future generations will have no say in the alterations taking place. Additionally, this raises the issue of liability. Cas9 can produce unpredictable side effects, which may not show until further down the line. If this were the case, who would the individual look for to blame? Furthermore, germline editing is considered acceptable in clinical research, but editing of embryos to create inherited changes is currently considered unacceptable and banned in many countries.